What's going on, guys? In this video we are going to see how to find the general solution of this differential equation using reduction of order technique. And here they have given a solution already. We are trying to find the another solution. Now in order to do that, what the first step is, we multiply this one by a v of t function, v of t times t square, right? After that we can get rid of this t function of t. Instead of that we just write vt square. Okay, and after we bring it into this pattern, then we take the derivative of this one. So first derivative, this is going to be a product rule because this is a function of t and this is also a function of t. So this is going to be a product rule. First we are going to have v prime t square, and then we are going to have v times 2t, so 2 times vt. Okay, so this is the first derivative. Now the second derivative is going to be, we take the derivative of this one. This is going to be a product rule. Also this is also going to be a product rule. Now let's deal with the first part. This is going to be v double prime t square plus v prime 2t, so 2v prime t. Now I'm doing the second part, this one. This is going to be 2v prime t, then plus 2v, that's it, 2v. Okay, so this is going to be the second derivative. Now after we find the derivative, we plug it back in this equation. That's going to be v, actually t square times v double prime. V double prime is going to be this one. This is y double prime, that's going to be this one. V double prime t square plus 2v prime t plus 2v prime t. So we can combine these two together. That's going to be just 4v prime t. This is going to become 4v prime t plus 2v. Then we have 3t y prime. So this is going to be 3t times, the first derivative is v prime t square plus 2vt minus 8y, minus 8 times y is this one, vt square. Okay, so here the key things to notice is the v value always cancels. The v values, when you add them together, it will always cancel. Now let's see whether it happens here. Now if you multiply this one by t square, this is going to become v double prime t power 4, and this is going to become 4v prime t cube, and then this is going to become 2v t square, and here we are going to have 3v prime t cube, and this is going to become 6v t square minus 8v t square is equal to 0. Now let's see whether all the v values cancels. Here we have 8v t square, and this is 6v t square, and this is 2v t square. We don't have any other v. And 6 plus 2, 8, plus 8, and here we have minus 8, so this will cancel. This will always happen. Okay, now we have this pattern. Now let's write them together. So this is going to be v double prime t power 4 and 4v prime t cube, 3v prime t cube. These are like terms, so we can add them directly. This is going to be 7v prime t cube. That's going to be equal to 0. Now what we are going to do is we are going to reduce the order, but before we do that, we have to have only one, like we just have to have v double prime alone. In order to bring that pattern, we have to divide everything by t power 4. So this will become v double prime 7v prime divide 7v prime t cube divided by t power 4. Then in the other side we are going to have 0 divided by t power 4, and this is going to be v double prime 7v prime divided by t, and here we are going to have 0. Okay, now we can reduce the order. Now we are going to substitute. Instead of v prime, we are going to substitute w. W is going to be equal to v prime, and instead of v double prime is going to be w prime is going to be equal to v double prime. Okay, now after that we are going to write this equation in terms of w. So this is going to be w prime plus 7w over t and that's equal to 0. Now dw we can write it as dw by dt. Okay, and also we can bring this to the other side because this is a separable equation. So you can see when I bring this other side, this can be separated. 7 minus 7w divided by t. Now we can separate the like terms and integrate. So if we separate these like terms together, that's going to become 1 over w dw. In the other side we are going to have negative 7 dt over t. Now we are going to integrate both sides. Integrate this side, and let's see what we get. Here we are going to have ln of w, and in the other side we are going to have minus 7 ln of t, and also we are going to have constant. Let's put k1. Okay, k1 for constant. Now to get rid of this ln, we can take e power. So I take e power both sides, this side e power, this side e power. Now I'm going to continue this one on top. Okay, we don't have enough space, and e and ln cancels each other, so this is going to be w. We don't have to worry about this absolute value, we can just write w. Okay, and here we are going to have e power negative 7 ln of t, and when we have negative 7 we can move this one to the power. In that way we can cancel this e and ln. Now let's write this one in that way. So this is going to be e power ln t power negative 7, and this one is multiplication because when the powers are adding, this is multiplication. So this is e power k1. Now instead of e power k1, I replace this one with a new constant. Let's call that one k2. So this is going to be w is equal to t power minus 7 times k2. Okay, now we have this one, and remember that we took v prime for w, right? So we can plug this one back. So instead of v prime, we can write it as dv by dt, and that is equal to t power minus 7 k2. Right? Our purpose is to find the v value. Now this is dv by dt, first derivative. Now to get rid of this one, we can integrate both sides. Integrate both sides, and this is going to become v. I'm taking the derivative integration with respect to t. This is also respect to t, and if you do the integration here, you have to add one more to the power, and you have to divide by that power. So this is going to be 1 over minus 6 t power minus 6, okay, times k2, and 1 over negative 6 and k2 is a constant. Both of them are constant, right? So we can combine them together and add a new constant. Let's call this one k3, and also after we integrate, we are going to have another constant. Let's call that one k4. So we can write our new equation as v is equal to, let's separate this one. Okay, v is equal to k3 times t power minus 6 plus k4. Okay, now after we find out this v value, what are we going to do is we are going to plug it in this equation. This equation initially we created, this one, we are going to plug it in this one. Here this is v times t square, so v is this one, k3 t power minus 6 plus k4. I should put plus k4 times t square, and if you multiply you will get k3 t power minus 4 plus k4 t square. Now from this one you can see this solution is already given, right? When we put 0 for this k3 and put 1 for this k4, you will get t square. This is one of the solutions given in the question, right? So this is given, and here the new solution is this one. This is what we found out. This is a new solution. Now so we can write our final solution. The general solution for this differential equation is going to be y of x is equal to c1 t square plus c2 t power minus 4. So this is going to be the general solution for this differential equation. Now let's box this one with a different color. So this is the general solution for this differential equation. Now to verify whether this solution is correct, you can always check. You can always plug it in this equation and see whether you get 0. Now let's try this one. Okay, so this is t power minus 4. Now let's go ahead and plug it in this equation, but in order to do that, we have to know what is our y prime and y double prime. So let's say this is y of t is equal to y2t is equal to t power minus 4. So y prime is going to be negative 4 times t power minus 5. Okay, and y double prime is going to be plus 20 t power minus 6. Now let's go ahead and plug it in this equation. T square times y double prime, that's going to be 20 t minus 6 plus 3 t y prime. Y prime is this one, negative 4 t power minus 5, and then we have negative 8y. Y is this one, t power minus 4, and when we add them together we should get 0. Now if you multiply this one, you will get 20 t power minus 4, and here you will get 3t times negative 4t power minus 5. That's going to give you negative 12 t power minus 4, and here we are going to have minus 8 t power minus 4. That should be equal to 0. Now from this one you can see this is 20, and minus 12 minus 8, that's going to be minus 20. So 20 minus 20, that's going to be 0. So this is 0 is equal to 0. Therefore this solution is correct. Therefore this is going to be the general solution of this differential equation. I hope this helps. Thanks for watching.